So excited for it. So what we can see here on this slide, oh, there we go, is this time we're going to see, should we go into the toothpaste manufacturing, because we might want to. So we have tin 2 fluoride, and tin 2 fluoride is a very common additive to toothpaste. It's a source of fluoride, which, as you know, most toothpastes have, and it's pretty easy to make. It's a single replacement reaction with tin and hydrofluoric or hydrogen fluoride in the gaseous phase, and you get tin 2 fluoride and some hydrogen gas. So we want to know is how much of this tin 2 fluoride could we make if we have 30 grams of the hydrogen fluoride, and we have plenty of tin. So again, we don't have to worry about that. You can see it's different is because we're given grams and we want grams. So this is going to be the longest type of problem we have. So again, our given is our 30 grams of hydrogen fluoride, and the unknown is the grams of tin 2 fluoride. So it's going to be a 3 conversion problem because we're starting in grams, so we have to get to moles. Then we have to do our mole ratio to switch moles, and then we have to get out of moles. So you can see here, this is what it looks like as a problem. We have 30 grams of HF. I look up the molar mass on the periodic table, which is 20, and I'm dividing it by that because I want to cancel out my grams. Next thing I do is I go to my balance of chemical reaction and I look for my mole ratio. So in front of my tin 2 fluoride, there's nothing, so that's why there's a 1. There's no coefficient. And then if we look at our HF, there's a 2, so that's where the 2 comes from for our mole ratio. And then the last thing we do is we're getting the molar mass of our tin 2 fluoride, which is 156.7 grams per mole. Check that everything cancels, all your moles and stuff cancels. We're going to end up in grams of tin 2 fluoride, which is what we want. And we can make 117.5 grams of tin 2 fluoride, which is pretty good. So maybe we should make toothpaste. Who knows? The last type is kind of considered normal stoichiometry. Normal stoichiometry is percent yield, and percent yield is basically just checking how well you're doing with your reaction. So remember, when you do a stoich problem, that's considered the theoretical yield, which is the maximum. So remember, you shouldn't get more than the maximum from a problem. When you do the lab, what you get is you get the actual yield. So the actual yield is the stuff that you actually obtain in the lab, and then the percent yield is just calculating your efficiency, so how well you did. And percent yield is just the ratio. So it's the actual yield divided by the theoretical yield times 100, and you're seeing how you're doing. They're going to have to indicate with percent yield, when you're doing it, when you're not. So just kind of look out for it. It's just kind of like an extra step onto a stoich problem. So what we have here is we have a pretty common reaction with benzene and chlorine. Benzene, if you remember, is a pretty dangerous chemical, but it's used to make a lot of other chemicals. And you can see it's made up here to make aspirin and dyes and disinfectants. So it's just a way that they use benzene. One of the things they make with it is chlorobenzene, and they make hydrogen chloride. So they react 36.8 grams of this benzene, and then when they actually do it, so this is like when they do it in the lab, they got 38.8 grams, and they want to know what's the percent yield, like how well did they do. So the first thing we have to do is we have to do a stoich problem to find out what they should have gotten, the theoretical yield. So we have here, our given is we have 36.8 grams of the benzene. And since they made that chlorobenzene, that's our unknown. Like, that's what we want to find out. So our unknown is how many grams of the chlorobenzene we have. So it's going to be a grams to grams problem because we're given grams. We're going to go to moles. We're going to do our mole ratio. And then we're going to go back to grams of the new chemical. So it's the longest type of problem we can do. And you can see here, I started with my 36.8 grams of benzene. I divided by my molar mass. And again, the grams goes on the bottom because I'm canceling out grams. My mole ratio is a 1-to-1 because there's no coefficients out front, so it's just a 1-to-1 ratio. And then I looked up the molar mass of my chlorobenzene, and that should say Cl, I don't know, it cut off or whatever, is 112.5 grams. So the stoich is the theoretical, and theoretically, in a perfect world, I should get 53.1 grams of the chlorobenzene. Then to do the percent yield, what you do is you take the actual yield, which they told you was 38.8 grams, divide it by your theoretical, times 100, and they're only 73.1% yield, have their percent yield, which is not a very good yield. Now, maybe there's reasons for that. We don't know, but that would not be considered a good percent yield. So, like I said, you want to practice these, and then again, you're going to do some of these as worksheets, some of these on your test. You just want to make sure you can do these. A big thing with stoich is seeing the pattern. There's patterns all over the place, and if you see the patterns, the problems become a lot simpler.